Remember that one? We are doing our first chapter from examination point of view, but according to the book, it is chapter number 2 because chapter number 1 we already finished. It was a simple introduction we have here now. A very quick review what we did in chapter number 2 last time. Here we are doing the nonlinear solution of the nonlinear equation, and I told you what is nonlinear mean. It is a polynomial equation degree more than 1, or it is not polynomial. That means the power is not positive integer like this one, or transcendental equation, either majud trigonometric or exponential function or line inside the equation we call nonlinear equation. Then we are looking for the solution of the nonlinear equation. Solution of the nonlinear equation means such number alpha at which when we put the function jawab is 0. This is called the exact root. We are not finding the exact root. We are finding the approximation of the alpha. And then, of course, as I told you, alpha generally not given to you, but teacher give you the location, which means the interval give you, and he say alpha is inside the interval or not. And teacher can ask you, check alpha inside the interval or not. I give you last time. This is one of the good theorem we have here, that after finding f of x, take all the term one side, make one side equal to 0, give you f in the equation. Then f must be continuous inside the interval, and the value of the function at the end point of the interval must be opposite sign. Opposite sign means one negative, one positive. Then it guarantee alpha is inside the interval. And when alpha is inside the interval, then we can start. Then I also told you alpha must be real. Alpha may be simple or multiple. Simple means derivative should not be 0, and derivative equal to 0 mean multiple. Multiple mean repeating. Simple mean not repeating. This is the things we discussed last time in detail. It means we have to use numerical method for approximation of the simple and the multiple root. We will do inshallah today approximation of the simple root here. And for simple root, I told you we have to use 4 methods: bisection method, fixed point method, Newton method, and the secant method. And if teacher asks you to use the best method for the simple root, you go for the Newton one. That's the things we finish here now. And I told you also one more point, which is the important point here, that all 4 numerical methods for approximation of the simple root of a nonlinear equation belong to the iterative group, indirect group. And indirect group, you need 3 things to check. First, should be initial solution given, and it is given by the teacher. You don't care. Second, iterative method must be stopped. You need stopping criteria, and it is also given by the teacher. Anyway, either he give you number of iteration, mean number of steps, or he give you accuracy 10 minus something. And the third thing, that is the accuracy or number of iteration also given by the teacher. And number 3, which is the important thing, the method, iterative method may converge, may diverge. That you have to check. And I will give you inshallah the condition, don't worry. Now, we do the first method, and it is called the bisection method. It is one of the simplest, easiest method for finding the approximation root of the simple root of the nonlinear equation. When I call simple, remember that one simple thing is not very good. It is not a very good method, but it is very good in the sense that we always start with the simple things to understand the basic idea. So this is one of the good method. From starting point of view, we have that we start with the method with a very simple one. Now you have to, each bisection is a iterative method. So as I say, you must know the 3 conditions, that it is iterative or not. Yes, it is iterative method. The first thing you must know. Bisection is an iterative method. And I told you, when you know it is iterative method, you must know what? How many initial approximation we need and how many initial solution given by the teacher for that one. To start, it need 2 initial solution to start, because iterative method never we can use if initial solution is not given. They must need the initial, and it need 2 initial solution to start here. And what is the third important things for the method? I told you, iterative method may converge, may diverge, and I give you the condition for the bisection method, which is a very good point of the bisection method. And what is this one? Is it always converges. This is a good point for the bisection method. And now what is the bad method? And when you know converge, we also know slow or fast. This is the bad point, but very slow. Very slow mean if we want to find the good approximation of the exact solution, we have to use the bisection formula many times. So before you start any method, you must know the basic of that method. And this is this. What is the bisection method? If someone asks you, what do you mean? What is bisection method? You say it is iterative method. It need 2 initial solution to start. The good point for that, always converge. But the bad point is, but converge very slow. Now, this is the things. Now, let's recall this one here. Sometime we bracketing method, interval handling method. This is a 2 different name of the bisection, but generally we call in exam is the bisection methods here. What is the bisection method? Is basic idea of the bisection method is what? We have to check first, always for every problem in chapter number 2, alpha mean exact solution. Alpha must be inside the interval. And our interval is slightly big. And what bisection method do? He convert your big interval into the smaller interval. And when you convert into a smaller interval, alpha still موجود in it. It means you are coming closer and closer to the alpha. Right? This is the basic things we have here now. As I say, whatever the method you do in chapter number 2, what is your first condition, please? What you need in the first thing? I told you last time. You always need the function. And how you can find the function? You take all the term from the given nonlinear equation on one side, make one side is equal to 0. Right? What is the second things you need, please, in chapter number 2? I told you last time. You need the location of the alpha, the interval, where alpha is موجود inside here. And how can you check alpha موجود inside, please? Which I also told you last time. Any student? How can you check?
Find
Substitute.
Yes, we have to check F must be continuous in the interval. I'm right? And what is the second condition? The value of the function at the end point of the interval is must be opposite sign, 1 negative, 1 positive. Then it is 100% guarantee to find the approximation of this. When we have this guarantee, what is next job? Next job, we need the help, and need the help from numerical method. And our first method is what? The bisection method. This is the basic things for each things, please, in chapter number 2. You must know this one. You need what? Teacher give you what?
Function.
No, teacher give you equation, right? Teacher give you first what? Non-linear equation. And from non-linear equation, what is your job to do? You find out
The function.
the function. And I told you how to find function. Take all the term on one side, make one side is equal to the z. And then you need interval. Then you have to check, because we, as I told you, 99.9% chance alpha is given, only location given. Then we have to check alpha majood in the location or not. How to check this one? We have to check these two rules. Function must be continuous in the interval, and the value of the function at the end point of the end is less than 0. Then it is 100% guarantee alpha majood inside the interval. When we know the location alpha inside, now we are ready to find its approximation with the help of different rule. And we are using the first rule, which we call is a bisection method. A very, very simple method, as I told you. And what is the bisection method here? I told you how many approximation need for this method? In the first,
Maybe 3.
No, 3. Wallah, who told you 3? I told you 2 initial approximation. 2 initial approximation to start. Right? If we want to use bisection method, please remember that one. Bisection method is an iterative method, and iterative method we cannot start unless initial solution given. Some iterative method need 1 initial solution to start, some need 2 initial solution to start. Bisection need 2 initial solution to start, and initial solution, I told you, always given by the teacher. So what you have to do here, teacher always give you what? Teacher always give you the interval, right? So interval mean A and B. So it's mean A is your first approximation and B is the second approximation. So with the help of 2 approximation, you can find out the many new approximation, and with the help of the formula, and formula is a very simple one. This is a formula we have called bisection formula. C equal to A plus B taqseem by 2. A is the first initial approximation, B is the second one taqseem by 2, and C is what? C is a new approximation. C is a new approximation, and this is generalized way I give the formula. Cn is equal to an plus b1 taqseem by 2, where n is greater than or equal to. So when you take n is equal to 1, what is your formula? C1 equal to a plus b, a1 plus b1 taqseem by 2. What is a1? As I told you, a1 is just mean a given by the teacher. B1 is what? Just a b, and you can find C1, and then you can find C2, C3, C4, and like this one. But what is the procedure for this method? How can you use the formula? Again, I repeat, bisection method need how many approximation? He needs 2 initial approximation. So how can you use here? After you check, you are given interval A. This is given your interval. And what you have to check, please, you have to check the value of the function at A and B must be opposites, right? If this is positive, this must be what?
Negative.
Negative. If this is negative, this must be positive here. Let's say this is positive. Value of the function at this point is positive, and value of this function at this point is negative. Then what this give you condition? This give you the condition that exact solution must موجود inside the
Interval.
interval. And when موجود inside the interval, you are ready to find its approximation by using the method we are using, the bisection formula, which is what you call C1, you call X1, whatever you like it. In the book, I say C. And what is C1 formula, please?
A1 plus B1.
Yeah, A1, B1, taksim by
2.
2. A1 is what? Same A. B1 is what?
Same B.
The B, right? Okay, you stop here. How many approximation you have now in total, please?
3.
We have a 3 now. A, B, and the C.
C1.
Now we want to find the second approximation. This is the first approximation. And when we find the second approximation, how many we need? The bisection formula need how many, please?
2.
Two.
Approximation.
How many we have here now? 3.
3.
So we have to pick what? Only
2.
2. How can we pick the formula I give you? Opposite sign. It means you have to check here what is the value of the function at C1. If C1 is negative, for example, C1 is the negative, can you give me what is your new interval will be?
A to C.
Yes, our interval is A and the C1. It's mean we have to ignore the last negative here. But if it is here is positive, what it
We
will be
take
the
B.
interval?
B to C.
C1B.
The
C1
B,
to B.
no, C1 to
B.
class. This is the things here. Now you can see when you have this interval, now what is your size of the interval become? C1 and the B, small interval. And now we know alpha is majud inside. When your alpha is majud inside, you are ready to use the formula. Can you give me what is the formula to find C2?
C1 plus B over 2.
Yes, C1 plus B taksim
Uh,
by
2.
2. If we want to find C3, so we need, how many we have here now? We have a 3, again 3 approximation. C1, B1, and
C2.
C2. Then we have to check again. C1 we are getting positive, negative, and this is a positive, this is negative, and this is positive. So we will ignore the last positive or negative. We choose only opposite sign here. You got my point? So it's mean you, when you have C2, then your interval C2 is here. Your C2 is what? You have C1, you have C2 and B. Now you have to check the sign of these 3. Must be opposite sign. Let's say the sign, this is negative and this is positive. It's mean what is your interval? C2 to
C2 to B.
B. So it's mean what is bisection? Basically, bisection method, each time he decrease your size of the interval, but when he decrease the size of the interval, alpha, exact solution, still majud in it. So it's mean if your interval becomes smaller and exact solution is majud inside, it's mean you are coming closer and closer to the exact solution. This is called the procedure of the bisection method. Very simple, this one here. But as I told you, bisection method, good point of the bisection method, always converge. Always converge mean when you find C1, C2, C3, always come inside the interval. This is a good point. And this mean converge and slow and fast. But if we want to come closer to the alpha by bisection method, we have to use the formula many times because it is very slow methods we have here. Okay, we have the first example for this case. This is the things. He say use bisection method to find the approximation to the root of the equation. Teacher not give you f of x. Teacher give you nonlinear equation and the location. And give you the stopping criteria. Stopping criteria, I told you, he give you two different way, either by number of iteration or by accuracy way. I give in the book here by accuracy way, but in exam generally he can give you by the number of iteration. That means find two iteration. Two iteration mean you have to find C1 and C2. If I give this example in exam, exactly the same example in the exam, I change it and I give this example. I say, this is a given problem. I say check the root of one of the root of this equation is majood inside the interval. This is the first part. And when it is guaranteed, find C3. Find the third approximation by using bisection methods. So what is your first job? Always find
f of x.
F of x. Take all the term one side, make one side equal to 0. So take 2x plus 1 on the other side, it becomes this one. And then check. First function must be continuous. Yes, it is continuous because this is the polynomial function. And you know that the polynomial function always continues. And now you have to check value of the function at the end point of interval must be opposite sign, negative and a positive. And now you use calculator. The value of the function at 1.5 is minus 0.625. Value of the function at 2 is 3. It's mean it is 100% guarantee your root, one of the root of this equation is majood inside the interval. We finished the first part. What is the second part? Find C3. It means you have to use the formula 3 times. Lest you find the first approximation because we have the guarantee. What is the first approximation? Formula is A1 plus B1 by Taqsim by 2. What is A1? 1.5.
1.5.
What is B1? 2. So we have 1 plus 2, 1.5 and 2, 3.5 Taqsim by 2. 3.5 Taqsim by 2 equal to 1.75. And we have this one. But teacher say find the third approximation. That means you have to use the formula one more time. But when you finish here, how many approximation you have? 1.5, 1 and 2, and new one, 1.75. You have to use only 2. You have to pick only 2. And how to pick 2? Should be opposite sign. What is that at A1? Negative. What is at B1? A positive. Now you have to check the value of C1, which is what? A positive. So it means, what is your new interval now?
A1 and C1.
Yeah, A and 1. This is your interval, new interval here, and alpha is majood inside here now. So how can you find C2? Very simple. C2 is what? 1.5 plus
1.75
Taqsim by
2.
And this is equal to, this is the second approximation. In exam, about 99.9% chance they ask you second approximation. Let's say we find the second, alhamdulillah, we finish the question. But in this, I say find the third approximation. Can any student give me what is the, to find C3, we need the interval. Can any student give me the interval, please, for C3?
A and C2.
A and the C2, because at A, we have a negative, and at C2 is a positive.
Positive.
So we will ignore last time. So your new interval is what? Your new interval is 1.5 and
1.625.
1.625.
to 5 and alpha majud in it. And what is your C3, please? 1.5 plus
Plus 1.625
1.625 taqseem
over
by
2.
2.
and that's the jawab. You can get, I think 1 point is a 5, 6 something here.
1.5625.
Yeah, that's the things you have the jawab here. And now you can see each time you use the bisection formula, you decrease the size of the interval. So how many interval you use now, please, here?
2.
We start from 1.5 to 2. And what we did? We find,
C1.
then we have new interval 1.5 and
7.5.
1.75. And we have what?
C2.
And then we have this one. So the same way you can find C4, C5 by each time your interval becomes smaller and smaller. But main good thing is alpha is exact solution is still majud in it. So when your size is interval becomes small, alpha majud in it, it means you are coming closer and closer to the alpha. But this is the way I give you problem in the exam. But in the book, I say, find the approximation by using 10 minus 2 accuracy. That means you have to check the difference between the new approximation and the old old approximation should be less than 10 minus 2. And that's the things we have. When I check this one, how many iteration we have to do? We have to find 6 iteration. And 6 iteration is too much. Of course, in exam, we cannot do 6 iteration. And your accuracy is very bad. Accuracy is not good. Accuracy is only 10 minus 2. Accuracy, good accuracy mean 10 minus 6, 10 minus 7. In 10 minus 2, we use very poor accuracy. How many times we have to use the formula? 6 times. If we want to use 10 minus, for example, 10 minus 7 accuracy, if we need 10 minus 7, we need maybe more than 20. So therefore, I say bisection method, good point of the bisection method is what? Always converge. But the bad point for the method is it converge very slow. That means to come closer to the alpha or get the good accuracy, we have to use the formula many times here. I will solve this example, same example, inshallah, later on. Remember, I told you we will discuss 4 numerical methods for the simple. And I told you one of the best for simple is what? Is any student remember?
Newton.
Newton. I solve the same example, inshallah, later on with the help of Newton method, but with the accuracy 10 minus 7. And you know how many iteration we need for that one? We need only 3 iteration. So how good Newton method is. And 10 minus 2 accuracy, bisection need 6. And if we need 10 minus 7, more than 20. But if we need 10 minus 7 accuracy by Newton method, inshallah, we'll see. And you will see you need only 3 iteration and you have a 10 minus 7 accuracy. Very good one. Faster conversion. But the problem with the Newton method is what? He never give you guarantee that always converge, like bisection give you. Bisection say, yes, always converge, but converge slow. But Newton method, not give you guarantee, may converge, may not converge. But when converge very, very fast. You understand now, please? You got the idea of the bisection method?
Yes, yes.
Okay. But this example will never come in the exam because this is very simple one. Why very simple one? Because when you use any problem in chapter number 2, as I told you, you need exactly two important things. One is a function, another is interval. And here function given, you can easily find function here. Interval is given here. And you can easily find out the interval, right? Not a difficulty, only calculation and you know the procedure. In exam, teacher never give you nonlinear equation directly. He give you some condition, and with that condition, you have to find nonlinear equation. And when you have a nonlinear equation, alhamdulillah, we can easily find out function, take all the term one side, make one side equal to 0. I give you the good example from examination point of view. It is this one. Very good example, example number 2.3. He say, find the point of intersection of the graph y equal to x cubed plus 2x minus 1 and y equal to sine x. Right? What does the point mean? Point mean x and y. Right? But in the bisection method, what you find, please? You find x or y?
X.
We find x only, not y. So, of course, what is the second part? Then he say use bisection method within the accuracy 10 minus 3 when a equal to 0.5 and b equal to 1. That means, but of course, in exam, teacher, I will not mention 10 minus 3 accuracy. I will mention you, let's say, second approximation. Then I give this example many times in the exam, but I mentioned then use bisection method to find the second approximation. Now, you need what? The function and the interval. What is your given only? You are given the interval. Interval is what? 0.5 and
1.
And 1. You need your first nonlinear equation. Can any student have the idea what is the meaning of the point of intersection mean? To graph the point of intersection mean is what?
The two equations are equal.
Equal. So then we can say here, this equation, not equation, sorry, function we call, because we call it the graph. It's a function. Graph of a function we have here. So we say these two functions are equal. It means x3 plus 2x minus 1 equal to what?
Sine x.
Sine x. Now you have the equation now. When you have this equation, what is your next job? Now you can easily find out your function, take all the term one side, make one side is equal to the 0. What is your f of x? X cubed plus 2x minus 1 minus sine x. Now this is become the easy one. This is your function now. X cubed plus 2x minus sine x minus 1. Now you have a function, you have an interval. Now you have to check one what? Is this one the x majud inside not? The x mean the alpha, majud inside or not? And how can you check? The value of this function at this endpoint of an interval must have opposite sign. And you can check here at 1, your function is what? Negative. At b, your function positive. Yes, guarantee, because they are opposite sign. It means this interval, there is alpha majud in it. Now you find the first approximation, a1 plus b1 taqsim by 2, which is what? 0.5 plus 1 taqsim by 2, which is equal to 0.75. And we have the first approximation. But we need what? Second approximation. We have to use the formula one more time here. Now we have here at a1 is negative, at b1 is positive. Now we want to check what is the sign of function at c1?
Positive.
is a positive. So we ignore the last positive. It means your new small interval is what? From A to the C.
So C1.
One. So what is your C2? This is your C2 now. Okay. And he say find the second approximation. Let's say in exam teacher say find the third approximation. Can you give me what is your interval for the third approximation, please? Any student?
C2, C1.
Yes. So we have is what? 0.625 to what?
0.75.
Yeah, that's your interval. And then you can easily find C3 is what? C3 is equal to 0.625 plus 0.75 takseen by the 2 we have. That's. But let's say in exam, I give you the second approximation and you find out this one. What is this one? This is your X. But you need what? The point. You need Y. And Y is what? This is Y given by you. And they are equal. So you can put 0.625 either in place of X here or in place of X here. Anything because they are equal. So what is the jawab? Jawab is 0.625 C2 and the sign 0.625. That's the job. You use calculator, find the value of 0.625 by gradient, and then you can have the jawab. You got that point? This is a very good example from examination point of view, please. But in the book, I solve by the accuracy 10 minus 3. So it's mean we have to find out the 8 iteration. And what is C8? C8 is 0.662189. And when we put this X value into the function, this is the function value we have here. Any question you have up to now, please? If not, say okay.
Okay.
Okay. Now, you remember as I told you that in 254, we want to, if we want to check our approximation are good or not good, we have to use two different formula. One is absolute error and other is error the bone. But remember that one, I told you the error, absolute error need exact jawab, exact root, which is I told you 99.9% chance we are not given alpha. We need another formula which we call error bound or upper bound, same thing. And upper bound or error bound does not need the exact jawab, it need only approximation formula. Now I give you the, what is the error bound formula of the bisection method in the form of theorem 2.3, and this is this one. This one is error bound formula of the bisection methods. Alpha minus Cn, alpha is your exact, Cn is your approximation, is less than equal to this one. Of course, we don't need to solve the left hand side, we solve the this value. What is B? The right hand side interval of, and what is A? The left hand side of the interval. And what is N? N is the number of iteration. Number of iteration we have here now. For example, in this question, my first question is what? Let's say, I say find the second approximation, and we find the second approximation, right? C1, C2. And the next part here, let's I give you one more part here, and I'll say compute your error bound. Compute your error bound, and the error bound formula is this one. So what is your error bound formula become? Alpha minus C what?
C2.
C2, because teacher say second approximation, it means n is 2, equal to what? B minus A taksim by 2 power
2.
2. That's the jawab of the problems we have here. But here a student always confused. You remember that one? For finding C1, what was the interval? Last example was 0.1.
0.5 and 1.
Yeah, 0.5 and 1. And we find C1. What we do, see, when we find C2, what was our interval? 0.5 and 0.75. But please remember that one here, either number C3, C4, whatever, when you find the error bond, the B and A will be the original given. Original is what? 0.5 and 1. Here a student confused. They say we find C2 with the help of this one. And they use A is this one, B is this one. No. Your B and A must be original we have here. And this is I solve it. He say find the error bond for your approximation. So what is the formula? Alpha minus C2 less than equal to what? B is your 1 original. A is your 0.1 original 1. Where taksim by 2 power 2, which is 4. And 1 minus 0.5 taksim by 4 is equal to what? 0.25. My question is C2 is good or not?
No.
It is not, because I say error bond always mean the jawab must be close to 0. But this is not close to 0, is a 0.1. 0.1 is a very big number. It's not close to 0. What we want close to 0? It should be 0.00 something like this one. And how can we get this value closer to 0? Any student give me idea? When?
We get C3, C4, C5.
Yes. When we have the value of n is big.
Increased.
Yeah. Value of n must be big. Big mean C3, C4, C5. Each time you have new approximation, your error is become smaller and smaller. And also remember that one. Sometime in exam, teacher also asks you one more thing. He say find the value of n with the given accuracy. If, for example, if we want to use, many times this question also come. If we want to find, for example, he say this same example I solve here, 10 minus 3, right? Now, let's say my question is what? If I want to find the accuracy 10 minus 3, how many times I have to use the formula? That means you have to find number of iteration. So what is the formula for this one? Remember this one is what? Ln 10k b minus a, b given by a is given by a teacher, and k also given because they give you 10 minus 2. So it means k is your 2. So you can calculate this value easily. So that's the 2 formula. Remember that one here. Let's I give you the last example for today. Then we continue next time. Yeah, this is a good example. I give minute to time here. He say find a bond. Bond mean error bond. Find the bond for the number of iteration to need to achieve the approximation accuracy 10 minus 1 to the solution of this nonlinear equation, which measure the interval with the help of bisection method. So first, he say find the number of iteration, mean find the value of n. Then after finding the number n, then he say find the approximation. That means if you find n is 2, you find C1n, C2. If n is 3, you need to find C1n, C2n, C3. Right. So what is the formula you have here now? 10 minus 1, it means k equal to 1. And a student confused, they use minus 1. No, because we say 10 minus k, and k is your 1. So what formula we have? Ln 10 power k, which I give you here before in the head. So ln 10, 1 B given, what is B given in the question? Is a 1 and this given ln by 2. You simplify. What is your accuracy? What is the jawab n? 2.3219. Of course, what is n? N is integer value. So we cannot take 2.32. We take the very next one. And what is, because you say greater or equal? Equal we cannot take because this is a real number. We need integer. And greater than this mean we take 3. So it means you need to find out C1, C2, and C3, which I find here. So we have this one. So of course, to find C1, first we have to check. Same way like we did 2 example. Value of the function at this point negative, at this point is positive. It's mean guarantee root majud inside, and then you find C1 is this one. Then check again. This is positive, so ignore last positive. So you have the interval is A1 and C1, which is I give you here. You find C2, and same way you can find C3, and that's the jawab of the problem. You got that point here? This is also very, very good example, but I will explain you inshallah next time here, because here is also, when I say something example is a good one, it always mean your f of x is not given. Your f of x is not given, because in chapter number 2, I told you what we need. We need f of x, we need interval, and if alpha given, alhamdulillah. If alpha is not given, alhamdulillah. We need this 3. But the third one, alpha is optional. Maybe given, maybe not given. But when you have the alpha, this example, you are given only alpha. You are not given interval. You are not given function. But when alpha is given, you can easily find out interval. You can easily find out f of x. That's I will give you discuss inshallah next time in the example number 2.6. Then we finish over the first numerical method for the simple root. Any question, please, before I take your attendance? Is okay?
Yes, okay.
Right.
Yeah.
Good. Right, let's take your attendance, please. Number 1, Isa. Number 2, Saud. Number 3, Abdullah. Number 4, Mashal bin Abdullah. Number 5, Muhammad bin.
Yes.
Yes, you are Majid. Number 5. Number 6,
Yes.
Muhammad bin, right? Saddam.
Muhammad bin Sattam, yes.
Yeah. Number 7, Makran. Number 8, Zaid.
Yes.
Number 9,
Yes, Doctor. Osama.
yes. Number 10,
Yes, doctor.
Hassam. Eh?
Yes.
Number 11, Mahand.
Yes, Dr. Muhammad.
Mahanan. Number 12, Mashari bin Abdul Mohsen.
Yes, present.
Good. Number 13,
Yes,
Zaid.
yes, sir.
Number 14, Fahad.
Yes, present.
Number 15, Abdullah bin Khalid. Number 16, Bandar bin
Yes, present.
Number 17, Umar bin Abdul Aziz.
Yes, present.
Number 18, Nawaf bin Abdul Rahman. Number 19, Ad bin Ali. 20, Muhammad bin Abdullah.
Yes.
21, Abdullah bin Umar.
Yes, present.
Number 22, Hadi.
Yes, yes.
Number 23, Muhammad bin Sulaiman. 24, Salman bin Namar. 25, Muhammad bin Ahmad. 26,
Present.
Muhammad. Huh?
Muhammad bin Ahmed, present.
Okay. Muhammad bin Abdul Rahman. 26.
Present. 26.
27,
27.
Hassan bin Khalid.
Yes.
28,
Yes.
Abdul Aziz. 29, Naif bin Saad.
Yes. Yes, Doctor.
Yeah, okay. 30, Wail bin Ali.
Present. 30 present while.
Okay. 31, Al Walid.
Yes, present.
32,
Yes, 32 Abdullah Saad.
yes. 33, Nasir.
Yes, Nasser.
34, Faisal.
Present.
Okay. 35, Sultan bin Saleh. 36,
Here.
Sama bin Abdul Aziz.
Yes.
37, Mashari.
Mishari.
Yes. 38, Sultan bin something.
Yes, present.
39, Abdullah Rahman.
Yes, present.
40, Abdul Mohsen.
Yes, present.
41, Khalid bin Nasir. And next one, Muhammad bin Ahmad. Finish, everyone? I think finish.
No, Doctor. I think my name is not in the sheet because I just they give me the cards before 2 days, so that's maybe why I cannot listen to my name. Khalid bin Fahad.
Khalid
bin Fahad. 43410.
You're Khalid now, and your number is 43.
Okay, 43.
Okay, inshallah, I will print the new one, then I will give you the correct number, right?
Okay, that's right. Thank you.
But up to now, you call 43.
Okay, I will call 43. Thank you.
Okay, see you then, inshallah. Have a nice weekend, but read that material, please, and we continue more in it.
Inshallah. Thank you, Doctor.
Okay, see you then.